Kom erbij. This is your final presentation. You have 1 hour. How you fill that in? Well, the floor is yours.
Good afternoon, everyone, or good morning for some of us. Welcome to the first Dragon presentation of today, namely that of Group H4. We figured it might be fun to start off with a word cloud of the main project description. Here you can see the main features of our project. Obviously, Dragon and Robot, but also the main sub-teams it's comprised of, like brain, bus, control, angle, radar, RF. Stop me if I've missed any. And the important features of the Dragon itself, like driving, line tracking, wireless communication, driving at a certain speed, turning, etc. Also a small detail I just noticed there in the D, it says detail, very small. And we noticed during the testing phase that it's in the small details the huge errors occur. But despite looking impressive, if I do say so myself, such a word cloud does not really summarize the project in a very concise way, so we try to put it all in one mere sentence.
So from the word cloud we just labeled this sentence. It's just a short description of the Dragon. It's a radio controlled robot, balancing on tools, everybody installed with radar, line tracking and display. From here on we will split this out and we will see what we have made from it. So the first specification, it's balancing on two wheels. It's a major specification of Dragon. The teams who are responsible for this are angle and control. So what did they do? What were they supposed to do? So angle, so like I'm seeing myself already knows, is angle calculation using distance sensors and gyroscope. This measurement of the angle is then passed to control, which uses it to drive the motor. Using their control loops, they have an angle control loop and a speed control loop. And we've heard rumors that they are experts at exploding chopper's.
Which brings us to the radio control part of the robot as implemented by Team RF. They were in charge of the wireless communication from a PC using a graphical user interface to the Dragon, sending commands from the PC to the Dragon and receiving back various information about the state it is in. Next up, the radar part. They implemented distance metering from the Dragon to the nearest obstacle in the current driving direction using ultrasound radar.
So this brings us to the last specification, but not the last T. That's line tracking and display. So the team involved in this is brain. So we will play short. So they had to choose from the commands using priority sheet. They were able to put dynamic content on the display and of course the line tracking algorithm where we have to drive the robot on a track marked by black lines. They were also supposed to implement it.
And last but not least, my favorite team, maybe because I was in it myself, connecting it all together, the bus team. We implemented synchronized communication over the bus lines on the backplane between the different modules.
So we are here today at the end of the integration phase. So we will go in on that now. Right, so we will first talk about the instant successes because we are positive thinkers. So as you can see, the sending of predetermined signals. These are signals that were hard-coded on the FPGA from radar or control to brain, and putting them on display worked almost immediately. Mainly, it was the work of So then the angle calculations using the distance sensors. This was also quite a success, and we could implement it on the control FPGA right away. And then after a long development time, that's true, but when the wireless modules were ready, they almost worked immediately. So it was quite a wonder. That was quick engineering. So we were able to send commands from through brain to control. So this brings us to the not so instant successes, as to say. Sending signals over the black plane whilst control drives the motor. Causes problems with noise on the bus lines due to inductive coupling. And the data was being received with a lot of errors. And it was only a problem when the modules were up and below the motor module. So what we did is we put the control board at the bottom of the dragon. And that solved the problem. Another problem was sending this from radar to brain. This was a two-way problem, let's say. It was a problem from brain and also a problem from radar. When brain calculated the low decimal, when brain decimated the low decimal and high decimal from the 2 decimal distance, we didn't hold the value. So there were the low decimal was changing independently of the high decimal, so this was saying nothing. So we had to hold the value. And also the radar had a bit of a noisy outcome. So yeah, that needed some fine tuning from the analog module and also from the digital module. And then communicating with the team control, this was really a hard one. The problem was that control was not able to receive any signal, and we were on this for a long time. And the problem was that in the system generator block there was a wrong clock period. A bit different in the clock period, so we debugged all the module, no errors, and then we thought, let's look at the system generator block, and there was a little parameter. So we should have done it further. After we worked on it for half a day, it was almost an instant success.
Finally, some rather large issues that caused quite some long hours of overtime here at the department, mainly for team control, fine-tuning the angle and speed control loops. I can still imagine them sitting there in the computer room, discussing amongst each other, maybe we need some more I, some more D, a little less K. Those are long hours, I believe them. Then for the angle team, measurement with the gyroscope, getting a decent value out of that. That took quite some time as well. And now these last few days with the radar, there was some timing issues, interference between the different pulses that were sent out through the ultrasonic radar. And now I guess what you've been waiting for, the end result. What works and what doesn't. Well, let's start off with the good news, I suppose. What works? The brain display can display various data, various information from the control and radar teams. Communication over the bus works very smoothly. All the signals get transferred between the modules. We can do line tracking, but with those small training wheels, because balancing it would need the gyroscope, which isn't fully functional yet. Wireless communication from RF to the Dragon works as well. They can command, they can send commands to brain forwards them to control, and thus the Dragon moves as it should. The Dragon can balance using the distance sensors from team angle on the control board, and it can drive at a given speed and turn whilst balancing. Then sadly, what doesn't? Our Dragon cannot breathe fire. This was a large objective for us at the beginning, and we are very sorry to not have implemented that. There are still some problems with the gyroscope. There is quite a bit of noise on the angle measurement there. So unfortunately we can't do the line tracking with that, nor drive up slopes. And then, like I said before, the interference problem with the radar distance metering.
So when we first did this picture is about the love for the dragon, not for each other. I will just give the project evaluation here. What different teams thought of it. Just a brief overview. Some sentences. The other team, some remarks other teams had. Or so, what did Engel think of it? They wasted a lot of time with non-working modules, and they would like to see it tested first. Brief remark. So that brings us to control. As other groups have said, first 3 phases should be shorter, but it was a very educational project. And they would also like to have a little bit more time to work with PCB. And they thought the workload was too high for the size of their team. I think we can say that this team had to do most of the work, most of the hours. And brings us to brain. We thought it was fun to work in large teams. It was very different from the other pianos we have done. It was nice to be on your own project first and then integrate them later on. So also very educational. But well, the major issue we had was, let's say, compilation errors. So the complexity was not very challenging of the brain FSM. But yeah, they've had their work with debugging.
And the radar team, as Control said previously, the first 2 phases were a little long compared to the last 2. So they didn't have much time working with the actual hardware. And this caused the module integration to be a bit chaotic because it came so late in the development cycle. And as you can see, this made them very, very depressed. The RF team, they would have liked to have more time to design the PCBs, or at least be notified it sooner in advance. And finally, the bus team, our motto was everything went better than expected. We had quite little problems during the final phase because we finished the entire implementation at the end of phase 3 as was requested. It was a reasonable request, of course. But this caused a drop in workload at the start of phase 4 because none of the other modules were ready to integrate yet. So, now we can actually show some things. The demo.